Well, good afternoon, everyone. Today I'm going to talk to you about ways in which we are using natural language processing in claims management at QBE. My name is Clara Castellanos. I've been at QBE for nearly 3 years now. I am a physicist with masters in math and a PhD in computational geophysics. So first, let's start with the business problem. As insurance companies or financial companies, we have been storing a lot of unstructured data and structured data, but historically, most of our models up to now have been relying only on structured data. So basically things that you can think of that come in tabular form. And the reason is it has been very difficult to actually tap into this unstructured data until recently. So NLP techniques have made great progress in the past couple of years. And we have seen not only the accuracy increase dramatically, but also computational resources have been made available to everyone with cloud computing. The other game changer, of course, has been that these techniques and models are very large and require a lot of data for training, but a lot of them have been open sourced. So now anyone can basically download these pre-trained models, and you'll have cutting edge NLP techniques at your fingertips. So these pre-trained models are really good, but if I want you to have one takeaway from this talk is that actually, all that unstructured data that you haven't used for years, now it's the time to use it, because you can use all of that data to actually fine-tune your pre-trained, off-the-shelf pre-trained models and make them just specific for your domain. And you will see how that will perform, how that will increase the performance of your models. So a little bit about QBE. QBE is a insurance and reinsurance company that has operations in over 27 countries, particularly in European operations. We are a commercial insurer, so we write very large risks. Large volume, large risks, it's important that we learn from historic claims to understand our risks and also improve the efficiency of the claims handling process. And of course, we have data that's both structured and unstructured. We have text, but we also have voice, we have images. And why is this important? Well, efficiency in good claims handling will essentially translate to a better customer experience, and you'll see that by things like a reduced claim life cycle and higher retention rates. And why, what are some ways that we can actually use NLP? So some points in the claim handling process are, for example, setting up the claim quickly, responding to common queries faster. Another way we're using it is to deal with repairs and payments as soon as possible. Also, identify those claims that are escalating in complexity and direct those towards more senior claim handlers. And ultimately, you'll be able to have a more personalized approach. You'll be able to, for example, send updates before they even get asked. So another thing that's really important is to actually have good semantic understanding of your data, because that is what will allow you to have a good understanding of your business and the risks that you're actually holding, and you'll be able to identify, emerging, trending risks. So what is semantic understanding of the data? It's something that goes beyond keyword identification and where context is key. So for example, if we have the 3 sentences that are below, the cat is playing, heavy rains and flooding, and water damage caused by cat. If I were to ask you, actually I'm going to ask you, if you go to the polls session, if I were to ask you which of the 2 sentences are more similar, I'd like for everyone to vote. You have 2 options, either first and third are most similar or second and third. So please vote what you think is most similar for you. There's no right or wrong answer. It's essentially going to be depending on the context that you have. So I'm gonna end the poll now just to get an idea. So basically, around 65 of you said that 2 and 3 are more similar, and the rest voted for the first and the third. So obviously, the first and the third sentence, they have the word cat. That is the same word. And if you're outside the insurance context, you may be referring to the animal. Those in insurance will probably recognize that cat is a short for catastrophe event. So those in insurance would have voted for the fact that 2 and 3 are more similar. And this is exactly what we are trying to get to. So we'll come back to that similarity in a moment. So let's go through a business, so just through a case study. Let's say we have a population of 6 claims. The 3 descriptions of the claims that are above are all related to theft. So they have been assigned a loss cause. All right, clicking this. So they have been assigned a loss cause that is theft. And the 3 claims that are the lower 3 claims have been assigned a loss cause that is impact. Now, as you can see, or as you can notice, although the first 3 claims are about theft, none of them actually use the word theft. And the same goes for impact. And actually, if you take a closer look, none of them actually use the same expression to talk about theft. Some of them say stolen, broken into, burglary. So it's, the different ways in which we express the same idea. So the process in claims is that when a new claim arrives, we actually assign a loss cause in the system. And it's really important because then reporting gets done by loss cause. So we measure risk and performance using this loss cost. So for example, if we want to track what percentage of our claims are theft claims, we will see that we have 50% of our claims are in theft. The problem is that the reality may be different. So we may have the same 6 claim descriptions we were talking about, but what could be happening is that, for example, we have duplicate loss causes. So for some reason there are 2 misspelled or very similar loss causes, and so this kind of situation you'll see it very common. And the other situation is that some claims may not actually have a loss cause assigned at all. So the problem, of course, is that when you're going to do reporting for risk performance, and somebody asks you how many of your claims are due to theft, you're going to think that only 16% of them. So it's going to give you a very misguided view of the risks that you're holding. So this is when word embeddings come in handy. So word embeddings are multidimensional representations of data points that could be word, sentences, documents, which are preserving semantic relationships. So what this means is that words that are similar are going to be placed closer in space. So this, for example, if we look at the figure on the left, is a 3-dimensional space where someone has taken the word king, man, woman, and queen, and what they're using it here for is to actually show analogies. So you can say that king is to queen as man is to woman. And the other thing that you can see, for example, is like the male version of these words are on one side of the data of the space, and the female version are on the other side of the space. So basically, what word embeddings are doing are they're taking our vocabulary and the knowledge and the context that we use them in, and they're mapping it in such a way so that the structure that it reveals is something that makes sense. So the analogies, the distance between points is just a reflection of the way we are using those words. So like we said, points closed in a vector space will have similar meaning, and the direction is encoding relationships, so like things like analogies. There are many different ways to obtain word embeddings. There are ways that don't involve deep learning, and there are ways that involve deep learning, of course. And the one that I'm going to focus on is BERT. This is a pre-trained model. This is a model that was released by Google in 2018, and they have actually, yes, released the weights, so open source the weights. So let's say the off-the-shelf BERT it was trained on the data, on billions of data that Google had access to, which is data of the internet, books, news, everything that you can think of. But it reflects, common English. And in insurance, the vocabulary is going to have words that are going to be more frequent than in general English. So, for example, the words claim and damage or policy premium, these pair of words are going to co-occur more frequently if we're talking about insurance than if we're not. So this is when I say that all that data that we've been storing for many years and has been unused is now it's the time to use it, because we can use that data to now fine-tune and fine-tune those pre-trained models. And what we'll see is that it's the final models that we use, the final embeddings that we use are more relevant to our business case. So how are we going to do the fine-tuning? So basically, we go back to our case study. Everything that was assigned a loss cost, first I want to say there are many ways to do fine-tuning. I'm just going to talk about one, of course, because of time. So one way is to go back to the data set that we had, and everything that had a loss cost assigned, even if it was a duplicate, we're going to consider that in our training data set. And everything that didn't have a loss cost, we're going to exclude it, of course. So what we're going to do basically is we're going to add a fully connected layer on top of BERT to create a classifier. And while we're training the classifier, what we're actually doing is updating all the weights from the whole model, including the weights that were in BERT. So we do that with the property claims, and then we extract the embeddings at claim level. We do a two-dimensional projection of these embeddings, and this is the kind of like the structure that the claims description for the property claims reveals. So this, as we can see, I want to point out a few. So if we go up here, what I'm circling with are the theft claims. So there are two loss codes. As we know, there were duplicate loss codes, and they are identified by the embeddings because they appear close in space, but also there's overlap. So we have successfully identified those duplicates that were present. If we go, like, for example, over here to the very right, we see claims that are related to denial of access. If we go to the very bottom, it's claims related to lightning and fire. And again, we have detected that there are two loss codes that are duplicates. Very to the left are hurricane claims. Those are very well-defined set of claims. And so the structure of the data is actually revealing, quite correctly what we saw, what we were expecting to see from our claim descriptions. So if we go back then to the original question that I asked you about the similarity of pairs of sentences, we're now going to compare off-the-shelf BERT with our fine-tuned BERT. So with off-the-shelf BERT, we're going to compute the similarity, the distance between pairs of sentences, and the smallest distance is going to represent the highest similarity. So for off-the-shelf BERT, the pair of sentences that is most similar is the sentence water damage caused by cat, and the cat, sorry, I can't read, the cat is playing, sorry about that. And that is what off-the-shelf BERT gives, because it is thinking that it's referring about the pet cat. Probably that's what it's finding. Now, if after we fine-tune our model in the way I showed previously, and we look again for sentence similarity, what we find is that the most similar sentences are now water damage caused by cat and heavy rains and flooding. So the fine-tuned BERT is actually now grasping the context of the insurance. So like I said at the beginning, when we are asking ourselves which two sentences are most similar, it depends on the context. So for general English, the model on the left is the answer, but for insurance-related English, we are actually this is what we want to see. We want to see that cat is actually at the cat event. So now, if we want to see this model in action, all we have to do is the first thing is identify the duplicates that we saw from the embeddings. So theft and theft, we will now rename them and remove those duplicates. And the next thing is, for example, take one of these unlabeled claim descriptions, run it through our fine-tuned BERT, and in this case, what we obtain is the loss code, loss cause theft. So now we can successfully say we have been able to actually go back and say, okay, of the claims we have, even though there were duplicates and unlabeled claims at the beginning, we now know that actually we do hold 50% of claims are in theft. So the key takeaways from this, from what I wanted to show you, is that what I wanted to tell you, what the main key takeaway is that you can leverage the power of all that historical data by adapting those off-the-shelf pre-trained models that you can download. And you will see that the quality of your predictions are going to improve simply because now they will be more adapted to your specific context. And I showed it for property claims, but each of you knows what is the best application for your business. And this similar technique that I showed of contextual embeddings, has a number of other use cases within claims. For example, for triaging or prioritizing claims, and also, for example, for identifying common queries in emails to generate those automatic responses faster, amongst others. And I will answer any questions. If there are no questions, which I think there are no questions, I'm sorry. Okay. So one question is, what is the biggest challenge with unstructured data that you're currently facing? So I would say that, okay, so I'm going to answer first what's the biggest challenge? So the biggest challenge with unstructured data in general, actually at the moment, we have different fronts. So we have data that comes from chats, data that comes from voices, data that comes from images, and obviously the text data. So I would say right now, I would say maybe not the challenges, but the biggest unexplored area for us is, I would say, maybe images, because we haven't been very good at labeling in the past. So that has been one of the biggest challenges with unstructured data, is finding like a good labeled data set that you can actually go and work with. The other question is, have you worked with non-English text? And does BERT work well in those contexts? Well, that's a very good question. So there are let's say BERT versions for many languages like French and Spanish and what they call low resource languages. And yes, they are equally they're very good. They're not as good as the English models, of course, but there has been a lot of effort to actually improve them, and cross-lingual even, more than when you have more than one language present in your data. That's also, there are also models that can work with that. Another question is, how do you handle large text with BERT? Isn't there a length restricted by the model? Yes. So there is, BERT, as all, let's say, transformer models, they have a length of BERT particular, I think it's 512 tokens. So anything longer than that, you can't put it in one go, let's say. So for, the approach that I've taken is, for documents, for example, that we've also used encodings for, what we have done is basically cut the documents into batches of 512 tokens, and then use some kind of pooling, or either averaging or concatenation, or some kind of form of aggregating those separate batches of 512 tokens. Oh, okay. So what methods do you recommend with unlabeled data? Okay, so yeah, so BERT is so BERT is a self-supervised model. So that's the beauty of it. So you don't need labeled data to have a language model. So it's self-supervised in the sense that language models, what they're doing is essentially predicting certain words in the sentence. So say you have the word, the cat jumped over the mat. If I can mask certain words in that sentence, for example, the blank jumped over the mat, and I use every other word in the sentence to predict the masked word. So you don't need label data to work with BERT. If you wanted to fine tune it the way I did, you do need label data, but there are other ways to fine tune. That's what I wanted to make a point there in my presentation. You can fine tune by just using your specific data and just doing more language modeling. Let's say just trying to do more language modeling on your specific data, and that is self-supervised, and you don't require any label data, which is yeah, that's the beauty of it, I think. How much human supervision has been required to check that the claim classification of the fine-tuned BERT once it was implemented? Yes. So I would say the human element is that you have to define what is a good criteria for you. So for example, for certain language models, there's a metric that is, for example, analogies. So remember how I showed that queen is to king as woman is to man. So when they were building that model, they had a list of analogies, and they wanted to preserve, they wanted to see if the semantic relationships were preserved. So, they trained thousands of models, and they had those pairs of words, and they computed the distances between them and saw which one was best. And that is what you have to define for your case, so that you're not having to go in and manually or visually kind of assess the quality of your model. So in my case, for example, the way that I defined when a fine-tuned model is good enough is because I had a similarity metric. I was defining what is the similarity under this new model of all the claims within a loss code. But of course, this is very specific to my application, and for another application, you're going to have to define what a good fine-tuned model is for you. But yeah, that's the one I used.